welcome to today's Tennessee at Home Learning Series. Today's lesson is for all our fourth graders out there, even though anyone is welcome to tune in. Today is the 13th lesson in our series. My name is Miss Pereira, and I am a fourth grade teacher at Venus Stewart Elementary here in Gallatin, Tennessee. If you didn't see our previous lesson, you can find it on the Tennessee Department of Education's website at www.tennessee.gov/education. You can still tune in to today's lesson if you haven't seen any of our others, but it might be more fun if you first go back and watch our other lessons since we'll be talking about things we've learned previously. Today we will be learning about multiplying two-digit numbers in mathematics. Before we get started, so that you can participate fully, you will need a pencil and a piece of paper and a space for you to work. I'll give you just a second to gather those materials. Let's start off our lesson today by reading a word problem to see how we might be able to help some students build a new playground for their school. Miss Cohen is the principal of a school, and she has a very special project for some of her students. Justin and some of his friends have been asked to help design a playground for their school. Mrs. Cohen, the principal, tells Justin that his part of the playground is rectangular and measures 20 feet by 10 feet. Help Justin find the area of his part of the playground. And we're going to be building onto our drawing as we go, so you're probably going to need your whole sheet of paper for this by the time we're finished. So kind of keep your first rectangle small as we draw. So let's start with Justin's part of the playground. What is the problem asking us to do? Yeah, find the area of Justin's part of the playground. So let's begin by drawing a picture. What shape is Justin's part of the playground? Yeah, a rectangle. The problem tells us it was rectangular. So let's draw a rectangle and label the side lengths. So if you notice, I'm not using up my whole paper because I'm going to be drawing something underneath and over here on each side. So what did the problem tell us the dimensions of Justin's part were? 20 feet by 10 feet. So let's label our dimensions. So let's make his length 10 and let's make his width 20. And what does the problem mean when it asks us to find the area? What is area? Yeah, how much space is covered in the playground? So how do we find the area of this rectangle? Correct, we're going to multiply 10 times 20 because area is length times width. And the length of Justin's shape is 10 and the width is 20. So what is 10 times 20? Let's see if you can think of that one in your head. Good for you remembering your strategies for multiplying by a multiple of 10. It's 200. Now we're going to get a little bit more information. Mrs. Cohen told Justin's friend Beth that she is going to design a piece of the playground next to his that's 8 feet by 20 feet. So let's add to the picture we have and draw Beth's part of the playground. Do you notice any similarities between Beth's dimensions and Justin's dimension? Let's label. This is Justin's. Correct. They both have a width of 20. So we can join Justin's rectangle with Beth's with her width of 20. But her length wasn't 10. Hers was only 8. So the dimensions of her rectangle were 8 feet by 20 feet. We don't have to label the 20 feet again because it's already labeled up top. If this top is 20, then the bottom is 20 as well. So how do we find the area of Beth's part? Yeah, we're going to multiply 8 times 20. So let's write that in our model. Let's label this as Beth's part. We know that area is length times width. And we know the length of Beth's rectangle is 8. And we know the width is 20. So thinking about our previous lessons, what is 8 times 20? Correct, 160. So we know that the area of Beth's part is 160. And now we're getting a little bit more information about the principal's special project on the playground. Miss Cohen told Justin's friend Chris that he has 2 parts to design. The first one is 10 feet by 4 feet. And the second one is 8 feet by 4 feet. So let's draw each of those rectangles in our picture. 10 feet by 4 feet. Let's focus on that first part. 10 feet by 4 feet. Do you see anywhere in our drawing that we have where we could easily add Chris's part? Correct, it shares a factor of 10. So we could add to Justin's part up here. We know that Chris's is 10 feet, so it can share this side of Justin's by 4 feet. So we can label this Chris part 1, knowing that the dimensions of this is 10 feet by 4 feet. And the second part of Chris's was 8 feet by 4 feet. Well, we can see that this already has a length of 8 feet, so we can join up with Beth's right here and join up with Chris's width of 4 feet here. Again, we don't have to label the 8 feet and the 4 feet because if this part's 8, we know this part's 8. If this part's 4, we know this part's 4. So now we can go through and find the area of each of Chris's parts. So let's start with his first part. We know area is length times width. And we know the length of Chris's part coming from right here is 10 feet. And we know the width is 4. So we know the area of his part, 10 times 4, a basic fact, is 40. Very good. And now for Chris's second part. We know area is length times width. We know that the length of this section of Chris's is 8. And we know that the width of this section is 4. Again, we have a basic fact. 8 times 4 is 32. And so now we have found the area of each small section of the playground. So now that we know the area of each small piece of the playground, how can we use this information to find the area of the entire playground? Correct, we can add up all the small areas or those partial products. So we can go over here to the side. We know that one section has an area of 200. Another section has an area of 40. Another section has an area of 160. And the fourth section has an area of 32. And we can add those up and see that the entire playground has an area of 432 square feet. Did you know that you can use an area model to multiply two-digit numbers? That's what we just did. And let's continue learning how to do that. Let's look at a new problem. Read along with me. There are 15 players on each baseball team of the Strikeout Club. There are 25 teams. How many players are on all of the teams of the Strikeout Club? What information is this problem telling us? Yes, it's telling us there are 15 baseball players on each of the 25 teams. 15 players on each team, and then there's 25 teams. So what is it asking us to find out? How many players are on all of the teams, or how many players in all? So we need to find out how many is 15 repeated 25 times, once for each team. What operation do we use for that? Yeah, since multiplication is repeated addition, we can just multiply 15 times 25. Let's see how we can use an area model to help us multiply these big numbers. Do this one with me. Let's start by drawing a pretty large rectangle. How can we break down each of these numbers to make friendlier and easier numbers to multiply? Remember, we're solving 15 times 25. Each factor is going to be a dimension of our rectangle. So let's make 15 our length, and let's make 25 our width. But I don't know what 15 times 25 is right off the bat. I need to break it down into some smaller numbers that I do know how to multiply in my head. So we can take our 15 and write it in expanded form. 10 and 5. And we can split our rectangle to show that. Then we can take our other factor, or our width, 25, and write it in expanded form as well. 20 and 5. Do you see how this looks like our model of Justin's playground earlier? So now we need to find the area of each smaller rectangle. These are called partial products, because we're finding the product of two numbers that are parts of our original numbers. So let's start with our largest rectangle. We need our length times our width. So we're going to use 10, part of our 15, and multiply it by 20, part of our 25. 10 times 20 is 200. Excellent. Okay, now let's do the next part. We're going to do our length and our width here again as well. We know that our length is 10 and our width is 5. So 10 times 5 is 50. Great job. Okay, now let's do this kind of long, skinny one. And we're going to multiply again our length times our width. We can see that our length here is 5 times our width is, coming from right here, 20. I know that 5 times 2 is 10, so 5 times 20 is 200. I'm sorry, we know that 5 times 2 is 10, so 5 times 20 is 100. And then our last section, our length here is going to be 5 times our width here is going to be 5. And that's just a basic fact that we should all know. 5 times 5 is 25. Excellent. So now that we found all the partial products, let's answer the original problem. To find 15 times 25, we just need to add all 4 of these partial products together to find the total area, just like we did with the playground. So we know that this part is 200. This part is 50. This part is 100. And this part is 25. And then we can just add them all together to get the total area of the entire rectangle, or our product, for 15 times 25. Correct, 375. I cannot write today. 375. Remember, there are different ways to use area models depending on the numbers in the problem. Sometimes you may find that you don't have to break apart both numbers to make it easier to multiply. For example, if you were multiplying 30 times 42, 30 has 0 ones, so you would only need to break apart the 42 to create your area model. Or you may already know your multiplication facts for 11. So if you're multiplying 11 times 56, you would only need to break apart the 56 to create your area model. Some of you may use a strategy like minutes on a clock to help you with multiplication, or quarters, because you already know 15 with minutes and a clock, or 25 with quarters. That's great. We always want to think about how we use math in our everyday lives. So let's think about what that would look like using an area model. Let's say you know your multiplication facts for 25, since each quarter in money is worth 25 cents. And we know there are 4 quarters in $1. We know that 25 times 4 is 100 because $1 is worth 100 cents. So let's set up an area model that shows 15 times 25. Write this with me. The same problem we just solved, we just might use a little different strategy to solve it. Draw our rectangle. Again, we're going to use each factor to label our dimensions. One factor is going to become our length. The other factor is going to become our width. But this time, because we're familiar with money, we're not going to decompose this 25. We're going to leave it. But we are going to break apart that 15 into 10 and 5. We're going to expand it out and divide our rectangle. So instead of 4 separate sections, we only have 2. We can easily multiply 10 times 25. What is that? Correct, 250. And then for our bottom section, we have our length times our width, which is 25. And because we're familiar with money, we know 4 times 25 is 100, and one more group of 25 is going to bring us to 125. Then, just like we did with the previous problems, we have to add our partial products to get the product for the whole thing, or the total product. So partial product 1, add the second partial product, and you can see that we get the same total product. 15 times 25 is 375. So based off what you know and the multiplication facts that you're comfortable with, you might break it up more or less to make the problem easy for you to solve. You may also recognize this as the distributive property. Because you just multiplied 25 by both 10 and 5. So what do we need to do to find 15 times 25? Yes, find the area of the whole rectangle by adding the partial products to get the entire area, 375. Let's think about what we learned today about area models and multiplication. How do area models make multiplying bigger numbers easier? I agree. We can use these models to break apart the bigger numbers into smaller, friendlier numbers using place value so that they're easier to multiply. And then all we have to do is add the partial products we found together. And we can even be flexible in which numbers we break apart. Remember, the goal here is to make it easier. Okay, let's try another problem. Let's try 48 times 23. Do these steps with me on your own paper. Let's go ahead and draw our large rectangle so it's ready for our numbers. To start, we need to break apart both our numbers and put them in the area model. So let's make 48 our length, and let's make 23 our width, and let's break them apart using expanded form. 40 and 8, split our rectangle into those sections. And then when we write 23 in expanded form, we get 20 and 3. And we'll break that apart as well. So now we have 4 sections that we have to go through and find the partial products, and then we'll put them all together in the end to find the total product of 48 times 23. So let's start here. We have our length times our width, 40 times 20. 4 times 2 is 8, so 40 times 20 is 800. Our length and our width here, our length comes from right here, 40 times our width, 3. 4 times 3 is 12, so 40 times 3 is 120. Our length here is 8. Our width is 20, so 8 times 20. Got my 20 from here. 8 times 2 is 16, so 8 times 20 is 160. And then our length here is 8 times our width here is 3. And that's just our basic fact. 8 times 3 is 24. And then we're going to go through and add our partial products to find our total product. So 800 plus 120 plus 160 plus 24. And when we add all those up, we get a total area of 1,104. How did you do? Okay, let's do another one. This time, you help me solve 12 times 16 using our area model. Let's go ahead and draw our rectangle. Let's make each factor a dimension. So let's make 12 our length, and let's make 16 our width. Let's go ahead and expand those out. 12 in expanded form, 10 and 2. 16 in expanded form, 10 and 6. And then you go through and find the partial products for each section, and then we'll check together. I'll give you about a minute to do that. Okay, great job. Let's check our work. We know that 10 times 10 is 100. 10 times 6 is 60. 2 times 10 is 20. And 2 times 6 is 12. Check your partial products and see if you got the same partial products as me. If so, we're on the right track. Now the last thing we need to do is add up our partial products to get our total product. $12 times 16 is 192. I knew you could do it. Okay, one more to try on your own before I give you some independent practice to leave you with today. This time I would like you to use the area model to solve 35 times 12. And I'm going to let you do it start to finish on your own, and then we'll check it together. I'm going to give you 2 minutes to do this. Okay, let's check your work together. Depending on how you chose to break apart your factors, it might look like this. You made 35 one dimension and 12 the other. You broke apart your 35 into 30 and 5, and your 12 into 10 and 2. So your partial products would have been 300, 60, 50, and 10. And then you would have added your partial products all together to get a total product of 420. Great job. Great work, everyone. Today we practiced multiplying two two-digit numbers using area models by breaking apart the numbers with place value. I hope you're seeing how using the area model can help you multiply two-digit numbers easily. You really did a great job. Here's your independent practice for today, which you can get from the screen, or you can go online to www.tennessee.gov/education. Thank you for inviting me into your classroom or to your home again today.
We know this year didn't go according to plan. Life occasionally springs a pop quiz on you, but you passed the test. Your family is proud of you, and Tennessee is proud of you. This year may have been different, but you met the moment and graduated. And we, at the Tennessee Department of Education, want to spend the next few weeks celebrating your accomplishment. Congratulations, class of 2020.